Hello everyone. In previous videos we have seen how to write a reactance diagram, how to write per unit quantities, all these concepts. In this video let me explain the introduction part for power system faults. So there are different types of faults occurring in the power system, and also these faults can happen or occur at different parts of the power system. And when there is a fault, the normal flow of the current will be disturbed, or I can say when there is a fault, it leads to the abnormal flow of current in the system. And when there is abnormal flow of current, this abnormal current can damage the components, and hence this fault must be cleared immediately by disconnecting the faulted part of the power system. And this can be done with the help of relays and circuit breakers. Relays and circuit breakers, with the help of these devices, we can clear the faulted part of power system. So as I said, so when a fault occurs, abnormal current flows in the circuit. So when I say abnormal current, this is actually a large current flowing in the system. So it's not only large current, it can be abnormal voltage also. So when a fault occurs at any part of the power system, large currents or I can say, so when there is a fault, large current and or large voltages are developed. This is actually very important, so you need to remember this. So when there is a fault, it is either a large current and or I can say it's a large voltage. So when there is a fault, it can be large current and large voltage, or it can be large current or large voltage, or it can be only large current. So these are the very important factors to be remembered. Okay, so these fault currents, which are many times larger than the normal currents, are called short circuit current. So when we say large current, so these are normally many times larger than the normal currents. What is meant by normal current? Normal current is when the system is healthy. When there is no fault, the current flowing in the system is known as normal current. So these are known as short circuit currents. So what happens when there is short circuit or when there is large current flowing in the system? When there is large current flowing in the system, this can cause a severe effect or considerable damage to the equipments connected to the system. So hence it is very necessary, or it is very important, the faulty section should be immediately disconnected. Say this is a power system, a line diagram of the power system, and say there are two branches and there is a fault in this particular branch. So this faulted section has to be immediately disconnected, or this faulted section has to be separated from the healthy part of the system. It is necessary that the faulty section should be immediately disconnected so that the other part of the system are not disturbed. Okay. Now under fault conditions, the relays give signals to the circuit breaker. How the system works: when there is a fault, the relays will give signal to the circuit breaker, and the circuit breaker trips and isolates the faulty section. So what happens is, in order to assure that these relays and circuit breakers are working properly, the proper setting of these equipment has to be done. So to obtain proper setting of these relays and the circuit breakers, the values of the system voltage and currents are very important during the fault conditions. So these values of voltages and currents determined by fault calculations. That is why we need fault calculation, and we need to know what are the different types of faults. Thereby we can calculate what is the fault current value and fault voltage value. So there are various causes for the occurrences of faults. So let us see what are the different causes. So what are the different causes for the occurrence of faults? I have noted few points here. See, the very important cause for the occurrence of fault is insulation failure of equipment. This is the general one. So when there is an insulation failure of any equipment, it leads to fault, or it is the main cause for the occurrence of fault. And the second thing which we can tell is due to the flashover of lines. Now how this happens? Flashover of lines happens due to over voltages, and when over voltages will happen, by, or these over voltages are caused by what? These over voltages are caused by switching surges, or I can say lightning strokes. So when there is lightning stroke, or when there is lightning, there will be a very high voltage or over voltage. Due to this, flash over can happen. So flash over is nothing but a short circuit or a fault. Now next one is permanent damage to towers. Now permanent damages to towers, when it happens, so permanent damages to towers can happen due to lightning strokes, and this can happen when lightning arresters fail to operate. So when lightning arresters fail to operate, this can lead to permanent damage to towers. So these are few causes I have listed for the occurrence of faults. There are many other causes also. So let us see now what are the different types of power system faults. So there are two types of power system faults, or I can say the faults that occur on a power system are of two types. One is symmetrical fault and the second one is unsymmetrical fault. So two types of faults are, one is symmetrical fault and the second one is unsymmetrical fault. So let's see what is symmetrical fault first, then we'll go to unsymmetrical fault. So when a fault occurs on a balanced three-phase system, so you know what is balanced three-phase system. So balanced is nothing but the voltage values across all the three phases will be same. So that is balanced three-phase system. So when a fault occurs on a balanced three-phase system, if the system remains balanced even after the occurrence of the fault, then the fault is called as symmetrical fault. So when a fault occurs on a balanced three-phase system, if the system remains balanced even after the occurrence of the fault, then it is called symmetrical fault. So the examples of symmetrical faults are, one is a three-phase fault, and the second one is a three-phase to ground fault, and three-phase open circuit fault. So these are different types of symmetrical faults. So these faults rarely occur in a power system. Only about 5% of the faults that occur in a power system are symmetrical faults. So these are very rare. So only 5% of the faults which occur in power system are of symmetrical fault type. So unsymmetrical fault is nothing but, so next is unsymmetrical fault. So unsymmetrical is if the balanced power system becomes unbalanced after the occurrence of this fault, then the fault is called unsymmetrical fault. So it is very simple. So here, even after in symmetrical fault, what happens is, even after the fault the system remains balanced, whereas in unsymmetrical fault, so once there is a fault the system goes to unbalanced condition. So the balance gets disturbed, so it goes to unbalanced condition. So such faults are called as unsymmetrical fault. So let me write the definition. So the definition goes like this: if the balanced power system becomes unbalanced after the occurrence of the fault, then it is called unsymmetrical fault. I said the only 5% of the faults are of symmetrical type, only 5% of the faults are of symmetrical type. So we have remaining 95%, I can say 95% of the faults are of unsymmetrical type. So we'll see various unsymmetrical faults. So under unsymmetrical faults we have 3 types. So first one is LG fault. LG fault is line to ground fault, single line to ground. So LG fault is line to ground fault, and LL fault is line to line fault, and LLG is double line to ground fault. Double line to ground fault. And it's written here, see, out of the faults which are occurring in power system, I said most of the faults are unsymmetrical, and out of unsymmetrical faults again we have 3 types. So we can according to the occurrence, we can say around 70 to 80% of the unsymmetrical faults are line to ground, and 10 to 15% are line to line, that is LL, and 5 to 10% are double line to ground, that is LLG fault. Okay, and I said symmetrical faults are only around 5%, and unsymmetrical faults are around 95% of the total faults. Though these are very small percentage, or symmetrical faults are rarely occurring faults, but these are most severe faults in the system. And all these impose heavy duty on circuit breakers. Okay. And unsymmetrical faults can be further classified as shunt type of faults and series type of faults. Shunt and series type of faults. So shunt type of faults involve short circuit between conductors or between the conductors and a ground. So what is shunt? So shunt type is short circuit between conductors or between conductor and ground. So shunt can happen. Shunt type of faults are nothing but it's a short circuit when there is a short circuit between two conductors, or we can say when there is a short circuit between conductor and ground. So here we said LG fault is line to ground fault. So this is a short circuit between a line, that is nothing but conductor and ground. So this is shunt type. LL is also shunt because it is between two conductors. LLG is also shunt. So all these are shunt type of faults. Okay. So when there is a shunt type of fault, these types of faults can be characterized by an increase in current and fall in voltage. So how these can be characterized? So shunt type of faults can be characterized by increase in current and fall or decrease in voltage. Okay, so this is the characteristic of shunt type of fault. So next one is series type of fault. So series type of fault is when one or two lines in a three-phase power system get opened. So series type of faults are nothing but when the lines are open. So when one or two lines in a power system get opened, these type of faults are called as series type of faults. Or we can say when there is a open between or open circuit between in a conductor, open circuit in a conductor or in a line, we say it is a series type of fault, and these can be characterized by increase in voltage and decrease in current, So for a series type, it is increase in voltage and decrease in current. So these are the different types of faults, and also under series type we have one conductor open fault, and second one is two conductor open fault. Three conductor open fault we cannot have. It's not if all the three conductors are open, then there is no question of saying it's a power system, because it's completely open. The system is open circuit. There can't be any current flowing in this system. Okay, so we have one conductor open circuit or two conductor open fault. So these are series type of fault. So this is just an introduction for different types of faults in the power system. The detailed explanation will be given in upcoming videos. So do subscribe to our channel, and please share and comment so that we can improve the quality of the content. Okay, so fine, that's it for today. Thank you. We'll see you soon with the next video.